Welcome back, class, to another lesson. Here's what we're on today. We're on 2.6, day 2. We're talking about domain and range using set and interval notation. So what we did in yesterday's lesson was we talked about graphing piecewise functions, which, just as a reminder, that was basically two different lines that had restrictions on them so that we had to erase stuff that wasn't true and keep the stuff that was true to then make a function. And today what we're going to be doing is we're going to be talking about the domain and the range of those functions. So what you're going to want out for your notes for today is you're going to want out the notes that I gave you yesterday. Those were problems 2 through 5 for the graphs, and then there's 6 through 12 on the bottom of that page. So you're going to want that out for notes, and then also the notes that I'm going to give you 6, 7, 8, and 9 for 2.6 notes day 2. So those two papers you're going to want out. So with this one, the value of this lesson, class, is, we can explain to each other what this graph looks like using a lot of English words. And that's great and stuff like that because we all speak English in here. However, it can get lengthy when we try to explain ourselves because we have to use a lot of words. Where in math, the beauty of a lot of the symbols is that you can write down 2 symbols which might take 3 sentences to explain. What's easier, to just write down 2 symbols and now we all know what we're talking about, or to say 3 sentences? As you can see, the symbols are very, very valuable, such as I can write down this symbol. And we all know that this symbol means equal to, like 7 is equal to 7, right? Or 5 apples is equal to 5 apples, something like that. Now I just explained that to you in about 3 or 4 sentences. However, all of you knew what was meant when all I did was write this. As you can see, the value of this symbol is very, very important. Just like the notation for set and interval. Another great thing about set and interval notation is that it is world known. People in Asia, people in Europe, people in Australia, no matter what country or what continent you go to, when they explain their math symbols, they use this notation. So you can actually communicate with a person with math problems and so on and so forth just by knowing this notation, because they will know that as well because they're also learning it. So it's kind of a universal type thing. That's the value of this lesson. Okay, so for this first one, we want our set and interval notation for number 6, x is greater than 5. For these first 7 or 8 here, what I'm going to do is I'm just going to do the interval notation first, and then I'm going to come back and do the set notation. So keep in mind, class, all I'm doing right now is the interval notation. Interval notation. So we want to explain ourselves. X is every number that is greater than 5. So 6 is greater than 5, 7 is greater than 5, 8 is greater than 5. We want to explain all of those numbers in that any number makes this statement true is greater than 5. And here's how we do that. If you kind of picture a number line right here, here's 0, here's 5, 10, 15, so on and so forth. If x is greater than 5, what we did back in elementary school is we put an open dot, oh, not there. We put an open dot at 5 because it's not equal to, x is greater than 5, so it's open, and then we shaded everything off to the right. And it went all the way up to 10,000, 20,000, a million, a billion, a trillion. It goes to infinity, right? Because we can pick an infinite number of values for x that make x greater than 5 true. So it goes all the way up to infinity. So here's how you explain that. Your interval. You're always going to read from left to right. That's how we do it in English. It's from left all the way to right. So where does it start off? Your values that make x true start off at 5. Now, does it equal 5? No, it's not greater than or equal to. It is only x is greater than. So if x is greater than 5, when it's not equal to, what you're going to put is you're going to put a parenthesis right here. So your left bound, where your true statement starts for this, is at 5 with a parenthesis coming before it. and then you're going to have a comma, and where does it end? It never ends, does it? It keeps going and going and going and going all the way to positive infinity. So when that's the case, you put down your graph starts at 5 and it goes to positive infinity. A sideways 8 is the symbol for infinity. And then you're going to put a parenthesis behind infinity. Whenever you write down infinity, a parenthesis always, always, always comes after it. Okay? So this is the correct answer. When you write down for interval notation, when you see x is greater than 5, our interval notation is parenthesis 5, comma, to positive infinity, parenthesis. That's how you explain yourself when x is greater than 5. All right, number 7. This might seem a little bit weird at first, class, but we do domain and range, interval and set notation for every single chapter that we do in Advanced Algebra A and Advanced Algebra B. So it might feel a little bit weird doing this at first, but I guarantee you you're going to become very, very good at doing this because we do it all the time. So for number 7, x is greater than or equal to 5. So now if we were to draw our number line again, here's 0, 5, 10, 15, so on and so forth. This time, x is greater than or equal to, so you're going to put a closed dot at 5, and everything is going to go to the right. Class, this part right here, I don't expect you to write down. This is just stuff to give you a better understanding of what's happening here, so don't worry about writing that down unless you want to. What I want you to write down is this part. And so now what I want you to write down is your left bound region starts first, and your graph is going to start at 5. Now, it starts exactly at 5 because it can equal 5. X can equal 5 to make this statement true. So if x can equal 5, instead of a parenthesis coming first like this one was, a bracket is going to come before it. That is our notation to tell us that x can equal 5. It is okay if x equals 5. It still makes a true statement. So our left bound is 5, and because it can equal 5, because it's greater than or equal to, you're going to put a bracket 5, comma, and once again, it goes all the way to positive infinity. So you're going to put a positive infinity. And always after infinity, you're going to put a parenthesis there. So that's the difference between number 6 and number 7. The only difference is that it's greater than as compared to greater than or equal to. When it's greater than, you use a parenthesis. When it's greater than or equal to, you use a bracket. All right. Now each one of these is going to build off of itself, so hopefully they aren't too difficult, but there is going to be an increase of difficulty level each one that we do. So pay very close attention. Number 8, this time 5 is less than x, and x is less than 7. To give you another visual, you don't have to write this down if you don't want to, but here's 5, here's 7. Now it says that x is less than 7. That was dumb. Here's 7. It says that x is less than 7. So if this is 7, I'm going to have an open circle here because it doesn't equal 7, it's less than it. And I'm going to shade everything this way until 5 is less than x, which another way of saying that is x is greater than 5. So if x is greater than 5, well then I'm going to stop right here, and I'm going to put an open circle right here. So all my values that make this statement true are in between 5 and 7, such as 6. 5 is less than 6. That's true. $5 is less than $6. 5 people is less than 6 people. 5 whatever is less than 6. And 6 is less than 7. So that makes this statement true. 6.3 makes this statement true. 5 is less than 6.3, and 6.3 is less than 7. However, once you get into this range or into this range, the statement is untrue, such as 4. 5 is not less than 4. That makes this statement incorrect. So that's what we're looking at on our number line. All right, so now to explain this using interval notation. Once again, class, I'm going to do all of these in interval notation, so every single one of these is interval. To explain this in interval notation, my left bound, every possible number that satisfies this is going to be said by stating my left bound first, which is 5. Can it equal 5? Your answer is no. X cannot equal 5 because this isn't less than or equal to. It is just less than. So 5, comma, and where do I end at? I end at 7. Can X ever equal 7? Your answer is no, because this is not less than or equal to. It is just less than. So it ends at 7. You're going to have a parenthesis at 7. And there is your answer, class, for number 8. 5, comma, 7. So now, going back to number 7, I'm guessing you could guess how to do number 9. 5 is less than or equal to X, which is less than 7. So now, going with this same number line, this is now just shaded in. So if 5 is less than or equal to X, your starting point is 5, and it can equal 5. So you're going to put a bracket there. It's less than or equal to 5, so it starts at 5, and it can equal that, so we put a bracket there. Comma, and we go to 7. It cannot equal 7, though, because this is not less than or equal to. It is just less than. So this is your answer for number 9. All right, moving onward. Number 10. This time, 5 is less than or equal to X, and X is less than or equal to 7. Because they are both less than or equal to, the only difference from 10 to 8 and 9 is this time they're both going to be brackets. We start at 5, and it can equal 5, so we have a bracket. And then it goes to 7. It can equal 7 because it's less than or equal to it, so we have a bracket. Bracket 5, comma, 7 bracket. That's how our notation is going to work for interval notation when we explain 5 is less than or equal to X, and X is less than or equal to 7. Number 11. X is less than 5, or X is greater than 5. When we explain this one, it gets a little bit trickier at this point. Let's draw it on a number line so we can understand what's happening here. All right, we'll say this number right here is 5. So X is everything that is less than 5. So we're going to have an open circle here because it's not equal to 5. It's everything less than it. So we go right here, and everything to the left works. And now we say, or X is greater than 5. So if X is greater than 5, once again, we're going to put an open circle here because it doesn't equal 5. It's greater than it. And it's going to go everything to the right because it's bigger than it or greater than it. So if you look at this one, you can pick every single number that exists to make number 11 true except for one number. You cannot pick the number 5 because is this statement true? Is 5 less than 5? Absolutely not. It is not true. Is 5 greater than 5? No, 5 is not greater than 5. 5 equals 5. So your only number that does not work is 5. X cannot equal 5. So if that's the case, once again, we're going to start off at our left bound. And our left bound, how far does this arrow go? It goes forever, doesn't it? Isn't a negative 100,000 less than 5? Yes, a negative 100,000 would work in this case. How about a negative 100 million? Yes, that's also less than 5. How about a negative 100 billion? Yes, that also works in this case. So negative infinity is where you're going to start. Now class, just like I said, a parenthesis always follows infinity. A parenthesis always comes before a negative infinity. You're never going to see a bracket with infinity. It's always going to be a parenthesis. Same thing with negative infinity. So you start at negative infinity, and how far do you go to the right? You're going to stop right at 5 because it doesn't equal 5. So it goes up until 5. And then you're going to have a parenthesis there because it doesn't equal 5. But that's not it, class, right? You've only covered all of these values. You haven't covered any of these ones. So what's going to happen is that you're going to have a union. A union means more values. Unions are denoted just by the U without the tail, though. So our traditional capital English U's, draw that just without the tail. So negative infinity, comma, 5. With a union, we're still going from left to right, so where does it start again? It starts at 5, and it doesn't equal 5, so it's going to be a parenthesis. And how far does this blue go to the right? It goes all the way to positive infinity. So you're going to put a plus sign, infinity, and as we said, infinity always has parentheses. So this is your answer for number 11. A negative infinity to 5, that covers all this. And now it doesn't include 5, there's an open circle there, but we're going to have a union. It picks up on the other side of 5 all the way to positive infinity. So that's going to be our answer for number 11. All right, number 12. We have x is less than or equal to 5, or 7 is less than x, which is less than or equal to 12. Whew! Let's put this on a number line so we can see what's happening. We have our number line. Here's 5, and here is 7, and here is 12. It says x is less than or equal to 5. So x is less than or equal to, that means it's going to be a closed circle, and it's everything going this way. Or 7 is less than x, which means x is greater than 7. You see how I can write that down? So we're going to have an open circle. X is everything bigger than it, so I'm going this way, except it's less than or equal to 12. So I'm going to have a closed circle at 12. It's less than that, so it's everything in here. So all the numbers that work for number 12 is in this red region here that I've drawn. Everything that's less than 5 and everything that's in between 7 and 12. So for our interval notation, we work from left to right. So start way over here at the left. What number is my left bound region? Hopefully you say it is negative infinity. We can go all the way back as far negative as we can possibly go. And we're going to have a parenthesis there because infinity and negative infinity always come with parentheses, never brackets. So negative infinity, and then where do I stop at? I stop right here at 5. Now, can it equal 5? Yes, x is less than or equal to. Because it's or equal to, I'm going to have a bracket right here. That means that it can be equal to as well. That's not the only red I see. I see more red up here than just this stuff. I also see this stuff. So I need to have a union. When I have that union, I'm also going to work from left to right. I see that it starts up again at 7. So I'm going to have 7. Is it going to be a parenthesis or is it going to be a bracket? Open circle right here, or you see that it's less than, not less than or equal to, so it's going to be a parenthesis. 7, comma, and how far to the right do I go? I stop once I get to 12. And now 12, is that going to be bracketed, or is it going to be with the parenthesis? It's going to have a bracket because it can equal 12. If it can equal it, it is going to be a bracket. So negative infinity to 5, union 7 to 12. Last one, number 13, when something is all real numbers, which means, well, I don't even know how to explain this, but on a number line, if we were to say x is greater than or equal to 0, or x is less than or equal to 0, well, there's no value that doesn't work. Any value you pick would be greater than or equal to 0, or it would be less than or equal to 0. So your number line has everything on it. Everything works in here. So that means we would say every real number works. We would say all real numbers. The way we denote that using interval notation, instead of writing down all real numbers, all you have to write is from negative infinity to positive infinity. And remember, those always have brackets that come with them. So negative infinity to positive infinity. And that is the end of that. All right, I hope that makes sense. Now, once again, class, this is all for interval notation. That is completely for interval notation. Set notation. For set notation, basically, all of these are written in set notation. X is greater than 5. X is greater than or equal to 5, that is set notation. The only thing different is that you have to write this, and this is kind of mathematical terms. You guys might think this is dumb, but you have to write this notation. X such that, and then you could just write this down. X is greater than 5. x such that x is greater than 5. And these always come in those squiggly brackets. I have one up here so you could take a look at it. I'm sure you guys have seen this before. And every math teacher should be able to write these well. I'm not one of those great math teachers, I guess, that can write these squiggly brackets, and I kind of feel bad about it. Maybe with more practice I'll get to it. But here's what I do. And you might laugh at me, but those are my brackets. So x such that x is greater than 5. That's what I want you to write for number 6 for our set notation. This is once again set notation. We're doing interval first. Now we're going back and doing all of them in set notation, which is going to be very, very easy because all of these are basically written in set notation besides the x such that with the squiggly brackets. So if x is greater than or equal to 5, we say that x such that x is greater than or equal to 5 with our brackets. There's our answer for number 7. Yep, number 7. Number 8, we say x such that, and then we write this down. 5 is less than x is less than 7. 5 is less than x is less than 7. So you guys could work ahead of me because that's all we do for all of these. For number 9, you're going to have a bracket, x such that 5 is less than or equal to x, which is less than 7. Close your brackets. This seems very simple right now. Once we get to our graphs, it's not going to be quite as simple as this, just to warn you, because our graphs won't have these written in interval notation like these ones are. But here's what we got for the next one. 5 is less than or equal to x, which is less than or equal to 7, and we say x such that with our squiggly brackets. This next one, we could write this down, class. Actually, why don't we do that? I'll come back to this one later. We'll say x is less than 5, or is it x is greater than 5? Or x is greater than 5. And then what you do here, x such that, and then you're going to have your brackets. Last two. You're going to write this whole thing down with x such that in front of it. X is less than 5, or 7 is less than x, which is less than or equal to 12. Put that in brackets. All right, number 13 is a big one. When we say all real numbers, we have our interval notation from negative infinity to positive infinity. When we want to write it in set notation, we say x such that x, and when we say x such that x, this symbol means belongs. Let me see if I can remember that again. No. X such that x belongs all real numbers, and there is your symbol. X such that x, this right here means belongs all real numbers. So instead of writing down that big huge thing, you can just write this down. I'll write down for you again. X such that x belongs, oofta. There it is. I knew that something was fishy about this one. Don't pay attention to this blue one. X such that x, this symbol right here means belongs, and this symbol right here means all real numbers. So x such that x, that weird looking E, that means belongs with the I and the R kind of swings along and hits the I. Those are Greek letters, by the way. That means x belongs all real numbers. So now, I'll write down one more time for you so that we won't get confused. X such that x belongs all real numbers. And this is set notation for all real numbers. So now when I'm going back to number 11, when we say that x is less than 5 or x is greater than 5, basically every single number works. So x such that x belongs all real numbers. You could write that down as long as you write this down, except x cannot equal 5. So this would also work for set notation on accelerated math. You might see it look like this. If you wrote that on a test, I would count that correct. So you might have that as well. So either one of these two would work for our set notation. Now class, I'm going to be picky on our tests as far as if you wrote down a bracket when you should have wrote down a parenthesis, or if you wrote down a parenthesis where you should have wrote a bracket down. I got to be very picky about that because that's how you're going to tell me what the function, what values exist for that function. So I have to be very picky about that because if you put down a parenthesis, you're telling me that it doesn't equal the number, where if you should have wrote a bracket, it means that it can include the number. So they're exact opposites, so I have to be very picky about grading that. So what we're going to do here now in the next video is we are going to use this information to do our set notation for our piecewise functions that we did on the notes the day before.